Hello, everyone. Welcome back to another tip of the month. Today, we will see how to 3D model data based on digitized information that was scanned on field. So, what we see here is data from an underground drift. So, as we can see here, we have the floor points and represented in green, and we have the back points that are in red. And the contour here is the drift contour in 2D. So what we see here are the 3D points and the contour in 2D. And with this data, we're able to model the 3D drift using Promine. So in the modeling category, we have the construct 3D drift command from the 3D drift module. And this command essentially allows you, like I said, to 3D model your drift. So we're going to click on this command. And first, you're going to select the date. So this is the date of the start of the drift development, whether it's a drift, a crosscut, etc. The layer here, we will choose 3D drift, and you can choose a profile as well. So these profiles are pre-configured, so you're able to configure them in the options so that when you're building your drift, you're able to see the shape that you want. So we're going to click on start, and we're basically going to follow the command line. So first, we'll pick the two sides of the wall. So we'll start here, and then we're going to pick the back. So that's the red dot or the red data point and the floor. And then we're going to start basically drawing opposite sides to develop the drift shape, essentially. And as you can see here, what I'm doing is that I'm following the contour in 2D. And as soon as you hit another set of data points, you can tell a program that I want to pick a new back. So this will be my new data point for the back and a floor point as well. So all that is using the command line. And as soon as you have two sets of data points, so the back and floor were initially here, and then you have the other data here. So the program is able to connect them using these two data sets. And essentially, you keep going, building your wall from both sides. And as you can see now, we have a new data set for our floor. So we're going to type F again for floor, pick the floor data point, and continue building the wall. And as soon as we're done, we're going to click on enter and select the last back point that we want and the floor point as well. And this will build our next segment of the drift. So each one of these are separate meshes that we can join later. And as you can see here, I missed a little part. So it really depends on the way that you want to model this drift. It doesn't have to follow the contour exactly. That you think that it's better to just connect these 2 points, then you can do that as well. It doesn't have to be exactly along the contour. And essentially, when you're done, you hit escape. And if we rotate this a little bit, we can see here that now we have this drift segment here. And once we're done developing all of our drift, as you can see here, now it's complete. And this is what it looks like. So this is your as-built drift based out of your digitized data from your mine. And now what we can do is perform multiple operations on this. For example, if we want to calculate the tonnage for a specific segment, then what we can use is the tonnage versus time command, again from the 3D drift. So if we click here, we can actually select a rock density and pick a segment out of the drift, which is here, hit enter, and in the command line, we can see the specific volume and tonnage for that segment of the drift. Alternatively, what you can do is select the date and time if you know which dates you want to include in your tonnage calculation, and the program will essentially go and find the drift segments that were built in this timeline and give you the volume and tonnage as well. And one more option that we can do is using the solids command. We have an option here to join 3D faces or to join or do a union. So this by selecting multiple meshes. So if we select that command and select all of our drift segments, this will essentially join all these little drift segments together, creating one complete mesh of the whole level of the drift. And when the program encounters a join problem because one of your meshes is not closed, it will give you these pieces left here, as we can see here. Other than that, the rest of the drift is joined. So this also allows you where you need to adjust your mesh, whether to close it or to redo it, basically. So this concludes our tip of the month. Feel free to leave any comments or questions down below. Thank you for watching.